All right, in our chapter all about area and perimeter of polygons, we're gonna combine two things that we've learned so far. Um, one being trigonometry and one being that area in this section. So our goal or objective for this section is to find areas of polygons and triangles using trigonometry. So we are going to have to use trigonometry from time to time to help us out with those things. So we're going to quick review some trigonometry. Um, it'll be valuable to have these written down, but to make sure they're refreshed in your memory. First thing is the classic trigonometry Pythagorean theorem. So if a triangle ABC is a right triangle, then a squared plus b squared equals c squared, where this is a, this is b, and c is the hypotenuse. All right, finding missing sides. Special 45, 45, 90 triangles or 30, 60, 90 triangles. We can use some special trigonometry there as well to find missing parts. So if you recall, in 45, 45, 90 triangles, two of the sides are the same. It's an isosceles triangle since two of the angles are the same. So we'll call those legs x. And the hypotenuse then would be x times the square root of 2. So the hypotenuse is the square root of 2 times bigger. With 30, 60, 90 triangles, there's another unique pattern if you know any of the parts of the triangle, where if you have the one leg, we'll just call the one leg, the smallest one, x. Um, the hypotenuse is 2 times that, always in a 30, 60, 90 triangle. And then the longer leg is the square root of 3 times x. All right, so we can use those special right triangles when we're dealing with trigonometry. There's also the classic sine, cosine, and tangent ratios, or SOHCAHTOA. So sine, the so would be opposite over hypotenuse. Cosine, or the ka in SOHCAHTOA, would be adjacent side over hypotenuse. And then tangent would be the toa, or opposite over adjacent. And it totally depends on what angle you're dealing with. So for instance, if I you can't use the right angle. Don't use the right angle. But you can use either one. If I'm using this one, we would have opposite, adjacent, and this is the hypotenuse. Okay, it would be different if I was using the other angle. So if I was using the other angle, this one right here, we would have, this would be the adjacent, this would still be the hypotenuse, and this would be the opposite. It depends on which angle you're dealing with. All right, then we can use some things with sine and cosine, which would be the um, law of sines or the law of cosines. This one is the law of sines. The nice thing about the law of sines and also the law of cosines is you can use these with any triangles. All of the other ones we dealt with had to be right triangles, but these can work for any triangles. Um, you can use the ratio sine A over the opposite side A is equal to sine B over the opposite side B. You can do that with any of the ones as long as you have two angles and two sides, or two angles and either one side or one angle. The law of cosines is for situations where you can't use the law of sines. It's a little bit harder to remember, I would say, because if you're finding, it's usually for dealing with finding side lengths, and it depends on the side you're dealing with. It's basically the same thing. It's the side squared is equal to the other two sides squared added up minus 2 times those other two sides times the cosine of the angle the opposite angle. All right, so if you're finding an angle, you're going to have to solve it then for the cosine portion of that. We're mostly going to be doing with the ones with right angles. So in this section, we'll be talking about problems like this. So finding the area of a regular polygon. Might as well review it since we're going to be doing that as well. Reminder, draw a picture to fill in the apothem. The one thing I want to highlight here is that the area of a regular polygon is equal to 1/2 times the apothem times the perimeter. or the apothem. And depending on what we're finding, we may need to use other formulas. For instance, just the formula of a triangle, the formula to find the area of a circle, the circumference of a circle. Just depends on what we're working with. So let's take a look at some examples from this section. Starting with this one right here, finding area. A stop sign is a regular octagon. The standard size has a 16.2 radius. So if this is our center, the radius would be going not from here to here, but from here to here. So from the farthest point out, this would be 16.2. What is the area of the stop sign to the nearest inch? Whoa! How do we know how to find the area of this stop sign? That's crazy. All we have is the radius. Well, let's look at this whole thing. It's an octagon, so there's 8 parts. So each of the 8 sections, the central angle is going to be 360 divided by 8. 360 divided by 8 is 45. So we have 45-degree angles, 45-degree triangles for the central angles. So we'll say this is 45 degrees. And I'm going to put the apothem to be a different color. So what I'm going to do is I'm going to take this part, one of these right triangles out. Whoops. Kind of enlarge it a little bit. Whoa. I'm just going to draw it better. Alright, so we have our right triangle. We know this part is 16.2. We need to find this part, the apothem. We also need to find this part, which we'll say is x, because we need to double it, or, well, we need to find the perimeter. So, 16.2, we know this angle right here is whatever 45 divided by 2 is, so it's going to be 22.5 degrees. We know this is a right triangle. So with right triangles, we can use a number of things. What I'm going to do is I'm going to use the trig ratios. We'll say, if we want to find A, that'll be the adjacent over the hypotenuse, so it'll be cosine. So cosine of 22.5 is equal to the ratio of the adjacent, which would be our apothem, over 16.2. So A is going to be equal to, multiply by 16.2 on both sides. We have A is equal to 16.2 times the cosine of, whoops, alright, we'll do the cosine of 22.5, it works a little bit different on this calculator. It's equal to that times 16.2. And apothem is 14 point, well, we'll round it to 15. Alright. That's one part we needed. Stuff is going all over the place. Alright. We also need to find the x. Um, to find that bottom, that base part, we're going to do opposite on hypotenuse. So sine of 22.5 is equal to x over 16.2 multiplying both sides by 16.2 will give us the x. 16.2 times sine of 22.5. 22.5, the sine of that, times 16.2 is 6.2. So if x is 6.2, our a was 15. I'm going to minimize this because that'll give us pretty much all we need for the rest of this problem. So remember, area is equal to 1/2 the apothem times the perimeter. So to find the perimeter, we're going to multiply 6.2. There's 2 of them per base, and there's 8 bases, so we're going to multiply by 16. 6.2 times 16 will give us our perimeter. 99.2. So our area will be 1/2 times 15 times 99.2. And we get 744. And we're dealing with inches, so inches squared would be our area. All right, now it took a while because I was dealing with a clunky calculator on here, and also we did have to use 2 different trig ratios to find missing parts. Now I'm not going to say that's the only way you could do it. There is ways to do this without using sine cosine. You could have potentially used the law of sines in depending on how you went about it. You could have potentially used the law of cosines. You could have used Pythagorean theorem after you found one of the other sides. There's lots of different ways you can do it. It's just you have to choose one of them. Now, number 2 is going to be done a similar way. It says a 15 gon with a perimeter of 90. We already have the perimeter there. We want to find the area. So you just have to find the apothem using trigonometry. Okay? There's enough information there to do it. If you were to pull it out, there's 15 parts to it, and each of the 15 parts would be a triangle again, if you want to make it a right triangle. But the perimeter is 90. 90 divided by 15 is 6. So each of these sides is 6. You can figure out what each of the angles are, and you have to find the apothem some way. So this part would be 3. All right? I'm not going to go through that one, but I'd rather go through one of these type of problems. Finding the area of the shaded region. Well, we can find, there's a couple different ways. We know the triangle is the regular, so we can use the area of the triangle. We could do 1/2 the apothem times the perimeter. But we'd have to find the base. We have the radius here, which in this case is also going to be the apothem of this triangle. So if we go about finding the area of the whole thing, subtracting the area of the circle, that would be equal to the area of the shaded. All right? So there's a couple of ways you have to do this. We have the apothem is, well, to find the area of the circle, we know we can do pi times the radius squared, so 6 squared. Already got that part down. To find the area of the whole triangle, we'd have to do 1/2 times the apothem, which is also 6 here, times the perimeter, which we'd have to find our missing thing. This is a regular one, so each, this is going to be a right triangle here, but each angle would be 180 divided by 3, which is 60 degrees. So then this makes this half of that, which is 30 degrees. So it's a 30, 60, 90 little right triangle right here. So that means that x is going to be, if this is 6, 30, 60, 90 triangle, this would be, x would be equal to 6 times the square root of 3. And we have x here, x here, x here, x here, and x here. So we have 6 of those because it's half of one of the sides. So we have to multiply that by 6. So the perimeter would be 36 square roots of 3. Now you can do the math. 1/2 times 6 times 36 square roots of 3 minus pi times, it's going to be 36, would get you the area of the shaded. Alright, that's how you'd set it up. Last thing I want to talk about for the sake of time is this one theorem, which is an awesome, awesome theorem. It's a formula for finding the area of any triangle. And you have to have, though, you do need to have kind of the side angle side type of thing, where you have two sides and an included angle. So the area of a triangle is half the product of two sides times the sine of an included angle. So here's how it would work. I'm going to do one example because this is an awesome formula. So to find the area of this, without having to do anything special, it's not a regular triangle. It's not a right triangle. We don't know the height right now. So you can use this formula. So area would be equal to 1/2 times 5 times 6 times sine of 133. And 1/2 times 5 times 6. So we have 133 sine of that times 5 times 3 is going to end up being, which is times 15. You get 10.97. So about 11 inches squared. All right. That's that formula. You can try it on your own with this one. I can show you the area. If you do it correctly, you'd end up getting 81.6 feet squared, I believe. All right. There is an error analysis you can try. See if you can find the error here. And 2 questions to end it. How can you use trigonometry to help you find the area of a regular polygon? And what information do you need to find the area of a triangle using trigonometry? Totally depends on the triangle though, right? So, this section on trigonometry and area, our goal is to find areas of polygons and triangles using trigonometry. We did both. These problems take a little bit of time if you're given minimal information, so it did take us a bit of time. But now you are able to connect the two things, finding the area of polygons and also this trigonometry. All right, that's it for this section. Have a great day.